Howdy, this is part 2 of Chapter 2 on one-dimensional motion. The definitions of velocity and acceleration, which relate those quantities to the position, are not algebraic equations that can be directly solved for the position if, for example, the acceleration is known. To obtain algebraic equations, we have to undo the derivatives. This is why in Chapter 1, great pains were taken to show that the process of integration is the reverse or inverse process of differentiation. Before reading this section, you should review that important part of Chapter 1. When you use integration to get rid of derivatives, you will see the meaning of the constants of integration that are part of the definition of the indefinite integral. These constants are shown to be related to the values of velocity and position at certain times. You should be able to obtain the algebraic equations relating position, velocity, and acceleration given any simple function of time for the acceleration. Exercise 1 is an example of a typical quiz problem you should be prepared for. You should of course be able to obtain the algebraic equations for the special case of the acceleration being a constant in time. It is important to keep in mind that the results for this special case only apply when the acceleration is a constant. A of t equals a sub c. For this special case, the algebraic equations you should be able to derive are v of t equals ac plus v at the time t equals 0, x of t equals 1/2 at squared plus v at 0 times t plus x at 0. Since these equations are often memorized in high school, they sometimes spring to mind under the pressure of an exam, even when they are not applicable. It would be best to know how to derive the appropriate equations from the definitions below for any acceleration and not rely on memory. A of t equals the time derivative of v of t. V of t is the time derivative of x of t. The best way to be sure you have mastered the material is to work problems. At first they all seem very different. That means you don't yet have a good enough understanding. If you do all the problems and exercises at the end of the chapter, you should see that the knowledge of how to obtain algebraic equations from any given acceleration is the common starting point. You should be able to determine the values of the constants of integration from the given information, the choice of an origin, the choice of when to call t equals 0. You should also practice translating a statement in English into an equation. For example, when do the two objects meet translates into what is the time t equal capital T when x1 of cap t is x2 of cap t. One final confusing point. A number of the problems and exercises involve either dropping some object or throwing it up. You are not given the acceleration, and without it, you can't begin to solve the problem. This is not at all trivial. We will only be able to understand in a truly logical way to determine the acceleration after we have learned about vectors, Newton's second law, the universal law of gravity. It is traditional, however, to expect students to solve these freely falling problems before getting the tools required to determine the acceleration. At this point, if you want to solve some such problems, you just have to use the result and let the understanding come later. On planet Earth, if you neglect air resistance, any object which is dropped will experience an acceleration of constant magnitude called g, independent of its size or weight. G is a positive number. The sign of the acceleration of a freely falling object depends on which way you call the positive direction. If you call up the positive direction, then a equals minus g. And if you call down the positive direction, which is perfectly legal, then a equals g. After doing problem 2 or exercise 6, you should see what a ridiculous answer you would get if you use the wrong sign for the acceleration, or if you use the right sign, but then used a negative value for g, which you might have been taught to do in high school. Suppose you were asked to find out how long would it take for a ball dropped from rest from a height h to reach the ground. You should start by defining what you mean by the positive x, or call it y, direction, and then choosing an origin. Any choice will work. For example, you could call up positive and the ground y equals 0. You could call the initial value of the ball's position y equals 0 and call down positive. You could call the initial value y equals 0 but call up positive. You could call the initial value minus h and the ground y equals 0 with down positive. Making sure to use the symbol g to stand for a positive number, such as 9.8 meters per second squared, you would have a equals minus g for the first case, a equals plus g, a equals minus g, a equals plus g. Whichever way you choose, you will get the same answer. If instead you start with some memorized results, don't say which way is positive, don't pick an origin, you might end up with this equation for t, the time required to hit the ground, as the square root of 2h over minus 9.8. Since the square root of a negative number is imaginary, this is nonsense. It's like saying, beam me up, Scotty, and disappearing into hyperspace. You should be able to start with all kinds of functions of time for the acceleration and obtain the algebraic equations that could be solved for position and velocity. You should have practiced enough problems so that you have no difficulty determining the values of the constants of integration and of translating certain phrases into equations, such as, when does it hit the ground? You can test yourself by going to the course website and looking at past exams. It should be immediately obvious which problems involve one-dimensional motion, and you should attempt them without using any books, notes, or consultants. If you have difficulty with any problems, ask about it in recitation, at the help desk, or in lecture. It does little good to watch someone else work problems if you have not tried them yourself before. If you have tried to solve a problem and could not do it, having someone show you how to do it will hopefully point out whatever was stopping you from getting a solution. You then at least know what you don't understand and can get help. That is the point of the problems. Determine that you know what you need to know, or pinpoint what it is you don't know so you can work on it. Good luck and gig 'em.